Hello, my little chemistry underlings. Welcome back from spring break. I thought this would be an opportunity to do a little bit of review. We left off with acid-base chemistry. Why am I starting us off with the concept of molarity as we resume picking up off of acid-base chemistry? And the answer to that is molarity is how chemists measure the concentration of solutes dissolved in water. Um, Acids have hydrogen ions dissolved in water of particular concentration, and we call that acidity, the measure of that. So I wanted us to start off with solutes to pick back up on that concept, refresh it after taking a little time off. So what do the directions say to do for this assignment? Make a copy of the document here, share it with me, and complete it using the simulation. When you open that in a new tab, which is what I want you to do, you'll get this open. I want you to open that with Google Docs. So click here, and then this will pop up. Now you have a document that you can edit. Before you do any of that, you probably do want to save it as a Google Doc. So click that, and it'll do the complete conversion of a docx file to a Google Doc. And now it's your own. I would like you to share it with me. Now, directions. The pre-lab. When you were dissolving salt or sugar in a beaker of water, how did you know it was a saturated solution or not? So the lab that we just finished off with, measuring the KSP of calcium hydroxide, that lab was figuring out the KSP of calcium hydroxide by finding the point of saturation, the point where any more of it led to a precipitate in the solution. So that kind of answers that question for you. I guess putting calcium hydroxide here. Calcium hydroxide. Let's go. Calcium hydroxide in a well plate. So calcium hydroxide in a well plate. If you design an experiment for another student for them to see some saturated solutions and some unsaturated solutions, what might you have them do? So here's where you might want to start by tinkering with the program a little bit. Here's what you see when you open the program from scratch. You see a drink mix, solute amounts. You can increase that. You see the molarity goes up. Solution volume, increase that. You see molarity goes down. Again, that's concentration, solution concentration. You can investigate different solutes. Cobalt 2 nitrate, cobalt 2 chloride, potassium dichromate, gold 3 chloride, potassium chromate. If you click on this, you get particular values of things dissolved solutes. This will be measured in moles. Your solution volume will be measured in liters. So now when we dissolve these things, remember copper 2 sulfate is a blue solution. You should remember that from class. Decrease that. This is almost completely clear. Oh, look at that. It is completely clear. It's water. Add a little bit more of it, though, and you start to get a blue tint, just like we did in class. Potassium permanganate. Oh, this reminds me. I got to show you guys this one. It's got a beautiful purple color. Anyway, I kind of wanted to leave this up to you to figure out how to use. However, just to show you an example, make a list of all the solutes and determine the solubility if possible. So I want a list of all of these, and each one of them may or may not have a particular value of molarity at which it starts to become saturated. So let's decrease our volume for cobalt 2 nitrate, and at some point, look at that. Nothing has changed except the concentration has gone really high. Let's see what happens when we do this with cobalt 2 chloride. Starting at the top, the least concentrated we can have is just pure water. Start adding some solute with the largest volume. Increase that, increase that, increase that. So we've maxed out how many moles we're allowed to add with this simulation, but if we decrease the volume, what happens? There becomes a point at which we become saturated. I want to know the exact point of saturation for this question right here. For each of the chemicals, if there is a point of saturation that you can figure out from the simulation. The next few questions in the assignment: what are the variables for solutions in the simulation? Which are independent and which are dependent? Again, what depends on the other? What doesn't depend on the other? So we're definitely solute amount, solution volume are variables. Concentration is also a variable. You could say saturation and not saturated or unsaturated are also variables. Which one depends on the other? You should label that as which one does depend on the other, being dependent, and which one doesn't depend on the other. So the amount that you drop into that beaker, does the amount that you drop into that beaker for cobalt 2 chloride depend on the volume? No, it does not. Does the volume of water that you put in here depend on the solute amount that is in there? Well, you actually could make a little argument that because this contributes to the volume, that it does depend on it. But I do think the logical thing for the purpose of this experiment would be to say no. But solution concentration definitely does depend on both of these things. So you want to label those appropriately. Then finally, you're going to design an experiment to determine the relationship of one of the independent variables to the dependent one. Collect the data for more than one solute that you will have in your experiment. You're going to do this in Google presentations, Google Sheets, not Excel, Google Sheets. You can put the dependent results in one column and the independent in the other. It's going to look something like this. Then you're going to try and make a graph of it. So I went ahead here and opened up a Google Sheets presentation. I'll call it Molarity simulation graph. And let's just say 10, 20, 30, 40, 50, 100, 200, 300, 400, 500, and we'll call this cars, gallons of wash. So how many gallons of wash do you need to clean 10 cars? If you highlight this, go to Insert Chart. Sometimes this does take a moment. I'll make this bigger. So it's made our chart here for us. It's not actually a chart, it's a graph. But XY scatter plot's usually the best. You want a scatter chart. Why is that usually the best? Because it's showing your actual data points here. It's not yet making a trend line. So this is a perfect trend line right here. You can make a graph like this. Do go ahead and make sure that you have a proper axis labeled. When you click Legend, Legend is usually going to give you the opportunity to do things like treat labels as text. See what happens when you do that. Treat labels as text. I do want you to become familiar with using these features. Chart axis and titles. So based off of how I did this, do you want to use gallons of wash versus cars as your title? Sometimes the title that it picks from your y-axis does make sense. Um, but notice here that it already kind of made it for you, gallons of wash versus cars. So it put that verse there for you and said, okay, it's seeing how your y column changes versus your x. That's a standard convention in plotting. You do say that your y versus x. That's just a convention. You can say x versus y, um, but it is kind of standard just to say y versus x as the first one that you go with. Why? Because that's just something somebody said a long time ago, and everyone else kind of agreed it made sense to do the same thing. Um, but that's how you can make a graph of your data from what it's telling you to do in the student directions for the assignment. That's enough of the walkthrough. I'll go ahead and let you try it and see where you get.